Good morning, my dear students. Today we will study lesson 3, the equality of two algebraic fractions. We studied before how to find the domain of the algebraic fractions and how to find the set of zeros of the function. Today we will study how I can say that I have two equal algebraic fractions. First, I would like to tell you how to reducing the algebraic fractions. Reducing means simplifying. I have 3 steps. Number 1, I will factorize each of the numerator and the denominator. Step 2, identify the domain of the algebraic fraction before removing the common factors between the numerator and the denominator. So first step, I have to factorize up and down. Second step, find the domain. Third step, remove the common factors between the numerator and the denominators to get the simplest form for the algebraic fraction. Now open your booklet, page 41. Example, reduce. Reduce means simplify. Number 1, n1 of x equal 2x plus 4 over x power 2 minus 4. I have 3 steps. Step number 1, factorize up and down. 2x plus 4, I have 2 as a common factor. Highest common factor, take it out. Then open bracket, x plus 2. Down, x power 2 minus 4 factorized to be x minus 2 times x plus 2. Second step, find the domain. The domain is this r minus the set of zeros of the denominator. We can easily now find it directly from the brackets. X minus 2, so x here equal 2. X plus 2 equals 0, so x here equal negative 2. So the domain will be r minus 2 and negative 2. And the last step, I will cancel the common factors between each of the numerator and the denominator, which is x plus 2 and x plus 2. Cancel x plus 2 with x plus 2, and n1x will be 2 over x minus 2. This is the simplest form for the fraction. Exercise 2, n2x equal x power 3 plus 2x power 2 minus 35x over x power 3 minus 25x. Look to the numerator, I have x power 3, x power 2, x. So the first step, I have to take out the highest common factor, which is x. I choose the least power. So I will take x out. Then open bracket, divide by the HCF, x power 2 plus 2x minus 35, and this can be factorized to be x plus 7 times x minus 5. Down, I have here x power 3 and x. I will take x out, and this will be x power 2 minus 25, and this can be factorized also to be x minus 5 times x plus 5. My second step, to find the domain. The domain, look to the denominators. What is the value of x should make the denominator 0? X here equal 0, x here equal 5, and there equal negative 5. So the domain will be r minus 0, 5, and negative 5. Last step, I have to cancel the common factors, the repeated factors from up and down. I have x minus 5 and x minus 5, x and x. So the final result will be x plus 7 over x plus 5. Example 3 is very important. N3x equal x power 3 plus x power 2 minus 2 over x minus 1. My first step is factorize the numerator and the denominator. Look to the numerator here, x power 3, x power 2, but I haven't here any x. So I cannot take out the highest common factor. There is no highest common factor between the three terms. What should we do? I cannot factorize x power 3, x power 2 minus 2. This trinomial cannot be factorized. But I studied before in prep 2, two kinds of factorization. X power 3 give me somewhere difference between two cubes. X power 2 give me difference between two squares. And 2. So this negative 2 can be negative 1 plus negative 1. I can distribute it to negative 1 and negative 1. X power 3 will take negative 1 and x power 2 take the other. So I can write it as this, x power 3, this negative 2, I will take negative 1 here with x power 3 plus x power 2, I will take the other negative 1 with it. So I have two brackets, x power 3 minus 1 and x power 2 minus 1. Minus 1 minus 1 give me minus 2. Then I have difference between two cubes. Factorize this small bracket and big bracket. In the small bracket I write the cubic root, x minus 1. In the second bracket, first square, change the sign, first times second, second square. Plus, this can be factorized with difference between two squares, give me two brackets, x minus 1 and x plus 1. Down, x minus 1 as it is. Then, look at this, I have x minus 1 times x power 2 plus x plus 1 plus x minus 1 times x plus 1. I have here a common factor. Can you see it? Yes, x minus 1 is a common factor. So I can take it out, the highest common factor out, and write the as x power 2 plus x plus 1 plus x plus 1. X minus 1 out, x power 2 plus x plus 1 plus x plus 1. I can here simplify, collect the like term, 1 plus 1, 2, x plus x, 2x. So x minus 1 times x power 2 plus 2x plus 2 over x minus 1. Next step to find the domain. The domain is r minus the set of zeros of the denominator. Which value of x can make the denominator 0? Yes, 1. So the domain equal r minus 1. And the last step to simplify by crossing out the common factors x minus 1 and x minus 1. So the final result will be x power 2 plus 2x plus 2. Number 4. N for x equal x power 2 minus 36 over x power 3 minus 216. The numerator gives me difference between two squares, so factorize to be x minus 6 times x plus 6. Down, this is the difference between two cubes. 216 is a cubic number. We can check if it's cubic or not by taking out the cubic root of this number will be 6. So this is difference between two cubes. Give me two brackets, one small and the other is more bigger. The small bracket right here, the cubic root of each of the two numbers, x minus 6, then x power 2, change the sign, multiply second power 2. Okay? Then I want to find the domain. I have here x minus 6 and x power 2 plus 6x plus 36. When I check to the calculator to factorize this bracket, I will find that this cannot be factorized. There is no real roots for this trinomials. There is no real rule for this trinomials. So this doesn't belong to R. And the set of zeros here is just 6. So the expression x power 2 plus 6x plus 36 has no real roots, and you have to check it by using the calculator. And the domain only R minus 6. After that, I will cancel x minus 6 with x minus 6, and the final answer will be x plus 6 over x power 2 plus 6x plus 36. Equality of two algebraic fractions. The two algebraic fractions n1 and n2 are equal if number 1, the domain of n1 equal the domain of n2, and n1x equal n2x after reducing each of them. So I can say that I have two equal algebraic fractions if they have the same domain and they have the same after reducing. Example in your booklet, page 43. Example 1. In each of the following, prove that n1 equal n2. n1 equal n1x equal 3x over 3x minus 6, and n2x equal 2x over 2x minus 4. I will first find the domain of n1x. So 3x minus 6 equals 0, 3x equals 6, x equal 2, so the domain equal r minus 2. And simplifying the first function, n1x equals 3x over 3x minus 6, 3x over 3 open bracket x minus 2. I cancel 3 with 3, so the function will be x over x minus 2. Let's go to the other function. Domain of n2x, 2x minus 4 equals 0, 2x equal 4, so x equal 2, and the domain equal r minus set of 2. n2x equal 2x over 2x minus 4 equal 2x over, I will take here 2 out, 2 open bracket x minus 2, then I will cancel 2 with 2 equal x minus 2. So the domain 1 equal domain 2, domain equal domain, and n1 of x equal n2 of x. The two conditions are verified. Then n1 equal n2. Let's go to example 2 in page 44. n1x equal x over x power 2 minus 1. n2x equal 5x over 5x power 2 minus 5. Domain of n1x, I will take the denominator, x power 2 minus 1 equals 0. So x power 2 equal 1. X equal positive or negative root 1 equal positive or negative 1. So the domain equal r minus 1 and negative 1. To simplify the function, x over x power 2 minus 1 will be x minus 1 times x plus 1. And the domain of n2x, 5x power 2 minus 5 equals 0. 5x power 2 equal 5. X power 2 equal 1. So x equal positive or negative root 1. And x equal positive or negative 1. So the domain equal r minus set of 1 and negative 1. Simplify n2x. 5x over 5 out, x power 2 minus 1. So the function will be x over x minus 1 times x plus 1. So the domain equals the domain, and n1x equal n2x. So n1 equal n2. Let's go to example 3. n1x equal x power 3 minus 1 over x power 3 plus x power 2 plus x, and n2x equal x minus 1 times x power 2 plus 1 over x power 3 plus x. First, I will find the domain of the first function. I will take the denominator, x power 3 plus x power 2 plus x equals 0. I will take x as a common factor, x power 2 plus x plus 1 equals 0, x equals 0, and x power 2 plus x plus 1 has no real roots. I can easily know this by factorizing using the calculator. There is no real roots for this, so the set of zeros only r minus 0, and the domain is r minus 0. To simplify, the difference between two cubes give me these two brackets, x minus 1 times x power 2 plus x plus 1 over, here I will take x out, x power 2 plus x plus 1. I can cancel this bracket with that, so the answer will be x minus 1 over x. And the domain of n2x, I will take the denominator, x power 3 plus x equals 0, so I will take x out as a highest common factor, x open bracket, x power 2 plus 1 equals 0, so x equals 0, and x power 2 plus 1 equals 0, x power 2 equal negative 1, x equal positive or negative root negative 1, and this doesn't belong to R, so I have only one set of zeros here, one element. The domain is R minus 0. n2 of x equal x minus 1 times x power 2 plus 1 over x times x power 2 plus 1. I can cancel x power 2 plus 1 with x power 2 plus 1, and the answer will be x minus 1 over x. The domain equals the domain, and n1 of x equal n2 of x. Therefore, n1 equal n2. Skip page 45. This page will be homework. And now go to page 46. The example is, in each of the following is n1 equal n2. So the same idea. n1x equal x minus 1 over x. n2x equal x minus 1 times x power 2 plus 1 over x times x power 2 plus 1. The domain of n1x equal x, here x equals 0, so the domain equal r minus 0. And the function is simplified, by the way. Let's go to the domain of n2x. X times x power 2 plus 1 equals 0. So x equals 0, and we just solved this exercise in the previous example. X power 2 plus 1 equals 0. So there has no real roots. So the domain equal r minus 0. And when simplified, I will cancel directly x power 2 plus 1 with x power 2 plus 1. So the final answer will be x minus 1 over x. And the two functions have the same domain, and n1 of x equal n2 of x, so n1 equal n2. Example. If n1 of x equal x power 2 plus 3x over x power 2 minus 3x, and n2 of x equal x power 2 plus 10x plus 21 over x power 2 plus 4x minus 21. Prove that n1x equal n2x. n1x and n2x means after simplifying each of them, we'll get the same answer. So we directly find n of 1x without finding the domain. We didn't need the domain here, but we can find it, no problem. n1x equal x power 2 plus 3x. So I'll take x out by one factor, x plus 3 over, I will take x down, x times x minus 3. I will cancel x with x, so equal x plus 3 over x minus 3. Let's go to the other function or fraction. I just factorize directly x plus 3 and x plus 7 over x minus 3 x plus 7. So we cancel x plus 7 with x plus 7, so x plus 3 over x minus 3. So n1 of x equal n2 of x. So there is a difference between n1 and n2 and n1 of x and n2 of x. n1 of x and n2 of x means a function after reducing. But if I ask you to find to prove that n1 equal n2, you have to verify the two conditions, the domain and the simplifying form of the other two fractions. Your homework will be booklet page 45. See you next lesson. Goodbye.